Hello, today we're going to be going through LeetCode problem number 26, which is remove duplicates from sorted array. Let's take a look at the LeetCode problem. So basically LeetCode says, given an integer array num sorted in non-decreasing order, which is just increasing order in my opinion, remove the duplicates in place such that each unique element appears only once. And it's saying to keep the same order. So this is based, the next couple paragraphs are just saying that you need to use the existing array nums. You can't create a new variable to store the numbers in. Okay, custom judge, doesn't matter. So let's look at the examples. So basically it's saying nums is equal to 1, 1, 2. So you should return 2 because there's 2 unique numbers in here. And your nums array should look like 1, 2, and then they use an underscore, meaning it doesn't matter what comes after this sorted array or whatever. Same thing down here, nums is this value, the output is 5, 0, 1, 2, 3, 4, and then a bunch of extra stuff, doesn't matter. And don't forget, non-decreasing order, increasing, it's just increasing. Alright. So let's go pseudocode this. This is actually fairly straightforward. So if nums is 0, you're just going to return 0. We don't want to deal with it. So we're just going to define an integer for the counter, and we're going to initialize that to 0. We're going to loop through each number in nums and compare each number to the previous number. And if the numbers are not the same, we're going to increment the counter. And then we set the previous number equal to the current number. So we've got to be able to change the numbers, otherwise we're just comparing the same numbers all the time. And then you end the statement, end the loop, and then you return counter plus 1. And I'll explain why it's plus 1 here in a minute. And you end the method. Okay. So this is the method LeetCode gives us. If num's length equals 0, return 0. We define that variable equal to 0. Now we're going to define another variable called j, because we're going to compare two numbers, so we want to have two different variables for that. So we'll start that at 1, and j is less than num's length. So the reason we start that at 1 is if we started at 0, we'd just be comparing the same number, which is, you don't need to do that. So if nums j is not equal to nums I, then we're going to increment that counter. And then we're going to assign nums I equal to nums j. And again, we do that because if you didn't increase nums I, you'd just be comparing the same value to nums j all the time. Okay, and then we're going to return I plus 1. And the reason we do that is, let's say the array contained all the same number. So let's say it contained 5 number 1s. So you assign this to 0, and then you iterate through. Well, they're always going to be equal to each other because there's only one number, so it'll return 0. So you always want to add 1 to account for the first number, for the first common number. Or, I'm sorry, unique number. Alright, so let's pseudocode this. Or no, let's debug this. We've already pseudocoded. Alright, so I used my nums values 1, 1, 2, 3, 3, 3, 4, 5. So we assign the counter equal to 0, and we just start iterating through. And I put some watches over here. I know all this stuff's over here, but this is just kind of cleans it up so you only see the values we want to see. So nums I is equal to 1, nums j is equal to 1. So it just goes to the next value. And now it's equal to nums j is 2 and nums I is 1. So we're going to increment the counter. And then we assign nums I to nums j. We just keep going through this. Fairly straightforward. We have a ton of 3s, so it's just going to keep bypassing those. And what number are we on here? 5. Okay. Alright, so now we have I equals 4. And if you look at the value of nums, the initial value of nums, 1, 2, 3, 4. There are 5 unique numbers, so we return I plus 1. And the result is 5. When you look at the int array, it's 1, 2, 3, 4, 5, and then you have stuff after the array, and that's what the underscore is related to in the initial LeetCode example. And that is pretty much it. So let's try to run this in LeetCode. Okay, got this code right there. We run it. Accepted. And submitted. Faster than 85. Let's do it again. Let's see if we can get better than that. 100%. We have the fastest submission out there. All right. The very last thing I'm going to do here is go through the space and time complexity. So time complexity, the time it takes to run it, basically it's O of n. So as you add more values to the array, the execution time is going to go up. You have 1,000,000 values in your nums array. It's going to take way longer than if you have 5 numbers. And then the space complexity, LeetCode capped it at O of 1 because we had to use the same array, nums, to put all our values in. So it doesn't matter what the size of the array is because we're using the same array. So the space complexity will always stay the same. And that is it. As always, thanks for watching, and we'll see you next time.